Assalamu alaikum and greetings. My name is Rami Yassin, and today I will be presenting about my progress 2 for my project Resolvo, which is an NLP based system that used to manage clients' complaints and have an intelligent trachea. So what I did in progress 2 is that I finished chapter 3 and 4 and I have some draft for the SRS. So let's get into it. So what I did in chapter 3. So chapter 3 is about system methodology. What methodology I used in order for me to develop this system. So in order for me to develop the system, I researched about different methodologies that will work better with my project. And I stumbled upon waterfall agile hybrid methodology, which seems to be the most suitable for my kind of project. So what is a waterfall agile hybrid methodology? Waterfall agile hybrid methodology, it is a combination of agile and waterfall. Waterfall is being done at the planning phase, at the requirement installation phase, QA phase, and deployment phase, as you can see from the diagram. But agile is being done on the implementation phase. Why is it done in the implementation phase? It's because sometimes some systems need iterative behavior. Agile is an iterative of design, build, test, and then then integration testing. So it's an iterative process for the agile, and waterfall is a sequential process. You finish this, you finish that, you finish this. So my system is why I choose this waterfall agile hybrid methodology for my system. It's because that it's used for it's very suitable with my project since it has an AI element, AI components like Trigea, RAG, and NLP, which require continuous testing and refinement. So as you can see here, this is a development lifecycle phases for my project. First of all, you have the requirement, which is the requirement citation that I have done already, interviewing with my stakeholder and having some questionnaire, understanding what's the problem I'm trying to solve, which is done in a waterfall manner, right? Sequential manner. And then for the second phase, which is the design phase, is where I create the layout of my project. It's where I sit down and I uh, plan out what the project will be like. So it's where the architecture is being made, the database domain class is being made, the interface decision are being solidified, and using UML diagrams documented in SDD and SRS. So now when it comes to implementation phase, I divided my project into 6 sprints, each sprint covering a part of my project. One of the sprints is going to cover my client portal, one of them is going to cover the authentication, one of them is going to cover the AI services, uh, project manager and developer dashboard, and GitHub integration. So this is all I divide into sprints. Each sprint is done in an iterative manner in an agile form. And of course also deployment is done in an iterative manner when I will roll out my project from the developer environment into a staging environment and finally into production. So then also I outlined during chapter 3 the hardware requirements and the software requirements. For my project, in order to develop it, I need an 8 gigabyte of RAM minimum in order to run my backend and front end. And of course, I need some connectivity because LLM APIs uh, in the web. So I need to access them using RESTful APIs, HTTP requests. And for the end user, the end user requirement is mostly about having a browser in order for him to be able to use my web-based application. For the software part, what I landed on from the choices, from the different choices I had in chapter 2, I landed on the choices that's more suitable with my stakeholder, because my stakeholder currently is a company that make use of Angular, uh, Java, Spring Boot for backend. So I'm trying to make the software more maintainable for them, more suitable for them, because they are more specialized on those frameworks. So for backend, I made choice of Java Spring Boot, which is uh, which is built and inherits a lot of the characteristics of Spring MVC, and also Maven as a package manager for it. And for front end, I made use Angular, Node.js, and NPM as package manager for it. And for my data layer, I'm using PostgreSQL with extension of PG vector extension. And lastly, for the AI layer, I'm using LangChain 4j to integrate my AIs from the back end, and of course I'm using LLM APIs like Gemini API, OpenAI, or Mercury Inception too. So for the tools for development, it's better to use IntelliJ IDE for the backend and VS Code for the front end, GitHub and Git for the version control, and Postman for API testing. Now let's go for chapter 4, which is analysis and design. In this chapter, it's mostly talk about the requirements, the functional and non-functional requirements, and give you a simple idea of how I implemented those in my SRS, STD, and STT. So, how I collected my requirement. First of all, I looked at the actors, okay, and for each actor, I identify what the actor should be doing. So, for example, my main actor is a client. He should be able to submit tickets. He should be able to get self-resolution and also track tickets, confirm if it have been resolved or not. And then you have the project managers who can manage accounts, create accounts for clients, and review ticket classifications, approve or disapprove AI suggestion, developer assignment, etc. And for the developer role, who will be working on the issue to have direct integration from the developer environment into the front end of the application. So now, let's talk about non-functional constraints. Non-functional constraints of this application, I'm trying to make it as for performance to be able to detect duplication. If there was duplication in under 2 seconds, and it has JWT authentication for security and RBAC for managing users, and of course TLS HTTPS encryption. And for scalability, it should be able to handle a minimum 10,000 tickets without degradation. So this is the overall architecture of my project. So I'm using a three-tiered layered architecture, three-tiered modular client-server architecture. So with the presentation tier being my front end, which has the client portal, developer portal, and the project manager portal, which communicates back with my server, which is my back end, which is my application tier, which has JWT authentication and my APIs and everything that is about my business logic, which is the main modules that I specified in my use case that we'll see next slide. And also it has this modules communicates with the external services like the API integrations of the GitHub, of the LLMs, etc. And for the data layer, finally, it's I'm using PostgreSQL with an extension of BG vector in order to manage duplication detection and semantic search using cosine similarities. So this is the use case diagram that I created. You can see the actors, the client, developers, GitHub API, LLM API, and project managers. This GitHub and LLM are external actors. So what these actors do, I divided my use cases into 4 modules, which is issue lifecycle module, AI support module, administration module, and external integration module, which each have its own specific use case description, sequence diagram, and activation diagram. So let's talk about one of the use cases, which is the first one, which is submit ticket. So in order for us to submit ticket, first and foremost, the client fill up the ticket title and description, and attach, if there's a folder, it's attached into it. And then the system, it goes through a system pipeline in which detection for duplication is being made, and it checks if it's duplicate, and it tries to have self-resolution for the client if the issue is known before or there is documentation about it. So this is how you can see the sequence diagram, how the flow of it, at what case it happens, if there's duplication detected, how is the backend respond, if there is it could be self-resoluted, how the backend responds, etc. So, and also in my chapter 4, I defined the database design entities. And what are the main entities in my application? We have first of all the users, which contains all the credentials of the system, and the tickets, which is the main thing that the user creates, like client, for example. It contains the status of the ticket, the severity of the ticket, etc. And then you have issue classification entity, which stores AI generated results like the type, severity, and sentiment score. And then you have knowledge base, which used to index resolve tickets used by RAG, self-resolution module. And this is the mock interface. The interface, I tried to make it as much good for the user as possible to improve the usability, and it's easy to understand. As you can see here, this is submit issue module. Sorry, submit issue use case, which is my use case one. How it looks like: the person fills the title, description, and attachment, and then if there is it could be solved using AI. The AI suggests a possible solution, and then the user can confirm or not. And if it's a duplicate issue, it links it into another ticket that has been managed. So it prevent redundant acts. So this is all from my chapter 3 and 4. I also worked on the SRS and STD, and it will be included into the main report for progress 2. And that's all from me. Thank you.